Welcome back to another lesson in Algebra 2. Today we're going to cover lesson 1.4, which deals with what we call literal equations. Literal equations have numbers and letters in them, but they have more than one letter in them, more than one variable, in other words. So therefore, we are going to solve by rearranging the equation. We will not get to a numerical answer. You've done a lot of these in your science class, so hopefully you're familiar with them. If not, that's okay. I'm going to walk you through several examples, and I'm sure by the end of this video you will be very good at solving literal equations. Now don't forget that you're required to take notes, so I hope you have your pen, paper, and perhaps your comfortable clothing on so that you can listen and learn. Let's get started. In example 1, you can see that I have two equations written here, an algebraic equation and a literal equation. I would like for you to write both of these equations exactly as you see them, side by side, so that when we do the comparison, you'll be able to notice how the algebraic equation has the same steps as the literal equations. Now in this 100 equals 3x plus 25, can you think of what the first step is? You would be correct if you thought the first step is to subtract 25 from both sides. 100 minus 25 is 75, and let's write what we're not using, which is that 3x. Now that's the first step in the algebraic equation. Let's go over to the literal equation and see how we can take that same step and follow the same process. But first we have to recognize which one of the variables in the y equals cx plus b would relate to that 25. If you said b, that would be correct. So now what does that mean? That means we're going to take that b and subtract it from both sides. That would leave us with y minus b. Now remember from Algebra 1, you cannot combine unlike terms, so therefore we're just going to simply write y minus b. What we're not using is the cx. If you'll notice, the x is underlined, and that is the variable that we're solving for. So when it comes to literal equations, I just want to point out that the underlying variable is the one that you will get by itself. All right, back to the algebraic equation. What would be our next move? Now you'll notice that that 3 is multiplying the x. Since the x is what we want to get alone, how do you undo multiplication? That's right, we would divide. Whatever you do to one side, you do to the other. 3 goes into 75, 25 times. And that's what x equals. Don't forget, you can write this another way. You can also say that x equals 25. Both of those answers are correct. Notice we got to a numerical answer. Now let's go over to the literal equation and take a look at what we have to do now. Which one of the letters is the same as the 3 in the algebraic equation? The C, correct. So that is the one that we have to move over to the other side. How will we do that? Well, since this reads c times x, we will once again divide. Everything needs to be divided by the c on the other side, and that means that this will look like x equals y minus b over c. Now I want to talk about another way that we can write this answer. This fraction y minus b over c can be rewritten so that we can separate that y and the b into two different fractions. And how do we do that? Well, let's take a look at what it means. The y is being divided by the c, and what else is being divided by the c? That negative b. So how can I write it? Let's separate them in our answer. We can also say x equals y divided by c minus b over c. That minus sign, or negative if you will, became the minus sign, and that's perfectly fine to do. So what was the purpose to this equation and how we finished it off? I just want you to see that these two answers are the same. In example 2, 3m plus 9n equals 18. The variable that's underlined is n, so that is the one that we have to get alone. We're going to start by moving that 3m over to the other side. And I'm going to take that positive 3m and subtract 3m from both sides. A lot of people think that this is 15m, but that would be incorrect, and let's make a note as to why. You cannot combine unlike terms, so get that in your note. Cannot combine unlike terms. And so what that leaves us with is 18 minus 3m. We just have to leave it as is, and let's bring down that 9m. Now we have to get the n alone, so we're going to divide out that 9, and we're going to do it to the entire side on the right, leaving us with n equals 18 minus 3m over 9. Now, can you think about another way to write that? I just expressed it to you in the last slide. We can take that 9 and divide it into both the 18 and the 3m. So work ahead of me right now and go ahead and write the other way for this equivalent fraction. It would be 2 minus m over 3. These two things are the same, and it's important at your level that you recognize when things are the same. It would be the same as telling somebody who's learning fractions that 1/2 equals 50 over 100. That's hard sometimes for people just learning this, that would be true. And the same goes for you. These two things are indeed the same, and I want to make sure you understand that they are. So here we are with example 3, where we have negative r equals 5 times the quantity a plus b. The b is underlined, so that's what we're solving for. The quantity, or the parentheses, tell us to distribute. So we're going to take that 5 and distribute to the a, and we're going to distribute it to the b. So we're going to have negative r equals 5a plus 5b. All right, now since the b is what we're solving for, we're going to have to get rid of that positive 5a with the negative 5a and subtract it from both sides. We cannot combine unlike terms, so we're going to have negative 5a minus r equals 5b. All we have left to do is to divide out that 5. I'm going to go and divide it to everything on the other side. So let's just set this up so the b is on the left now. Doesn't matter where it is, as long as it's on the opposite side of the equal sign. And 5a minus r over 5. That is an answer, and a very acceptable answer, but I'm going to challenge you to once again find another way to write this answer. So we could write it how? Remember that the 5 is going into the negative 5a, and it's also going into the r. So if you just look at those independently and say negative 5a, kind of do this up in the right hand corner, negative 5 over 5, you would get negative a. So that's one possibility here. And the other one would be negative r divided by 5, and since that cannot be simplified, that would be the second part to this. So that's how I go about getting that negative a minus r over 5. Hope you got those answers, and now it's time for you to accept a you try. Here we go. You go ahead and try this A plus B plus C over 3, and that is division. It might be hard to see that division bar, so I'm just going to go ahead and draw it in for you. So that is a division bar. And so A plus B plus C divided by 3 equals D, and you are solving for the C. Go ahead and give that a try. When you come back, we'll reveal the answer. So how'd you do with that you tried? Did you get C equals 3D minus A minus B? Good news, it's time to end this lesson and wrap things up. Just a couple reminders that literals are very simple to solve for if you apply the same rules you used to solve the familiar algebraic equations. And also, when it comes to recognizing the fractions, they can be written several ways and still hold the same value. All right, if you have any questions, remember that you can ask them in class. Thanks for joining me today.